working on some KSP expressions and some calculations. Starting off with the simplest one, write the KSP for the following, and the equations are given to us, and the first one is iron phosphate, iron 3 phosphate, and then giving us iron 3 plus and phosphate ion. Now here you have to make sure that you're starting with a solid and you have aqueous, okay, in the products. Well, that's how it's usually going to be for most of the KSP problems. So then the KSP expression for this one is going to be simply iron 3 plus and then phosphate ion, and those are the concentrations. You don't have to divide it by anything because you don't have solubilities, you don't have solids in the KSP expression or any equilibrium expression. Let's look at the next one, which is chromium 3 hydroxide, again solid, and this is going to give us chromium 3 plus ions and 3 hydroxides. So the KSP for this one is going to be the chromium ion concentration, and we have 3 hydroxides, so that will be hydroxide and then cubed. Again, we don't have chromium 3 hydroxide solid in the KSP because you don't have solids. Okay, so simple enough. All right, then let's do a calculation of KSP. So you're calculating the KSP of silver carbonate of a solution that is 32 milligrams in 1 liter of a solution. So the first thing to do for any of these equations or questions is to go ahead and write out the equation. Okay, so you can clearly see what the solubility expression is going to be like. So here is this. Now it's understood that your left is a solid and your right hand side are the aqueous, but if you need to write it out, go ahead. If you don't do it on the exam, I'll understand because I know you have to conserve time. So anyhow, KSP for this is going to be equal to silver ion, and since you have 2 of those, that's going to be squared, and then the carbonate ion, okay, for that. So that's how it's going to be, which means what we need to figure out then is, of course, the concentration, which we will use the 32 milligrams of silver carbonate. So let's go ahead and do that. So 32 milligrams, convert that to grams first. So in 1 gram, you have 1000 milligrams, and then convert that to moles of silver carbonate. And in 1 mole you have 275.8 grams of silver carbonate coming from the periodic table, and then divide this by 1 liter because you're calculating for molarity, and so this is 1.16 times 10 to the negative 4 molar solution. Now this is a molar solution in the sense that this is for silver carbonate. You still need to find out the concentrations of silver and carbonate because that's what you have in your KSP expression. So then we'll go ahead and do one more calculation, and you can go on if you have more space. I did not, and so I'm going to do this over here. So 1 molar, and this is for silver carbonate times, and then how many moles you have. So you have 1 mole of carbonate in 1 mole of silver carbonate. Kind of, that's what we're trying to do here. So it's the same thing. 10 to the negative 4 molar carbonate ion. And again, if you're quick in this, then you don't have to go through all these details. You know what you're doing in those cases, especially like on an exam. Okay, so silver carbonate times, and then you have 2 moles of silver ions in 1 mole of silver carbonate, and now this is going to be twice of that, so that's 2.3 times 10 to the negative 4 molar, and this is silver ion. So now all you have to do is put them in your KSP expression. Yeah, some of these calculations are pretty straightforward. So for silver, it is 2.3 times 10 to the negative 4 because you had 2 of the silver ions in there. That's why the concentration is doubled. And then square that and then multiply it by the concentration of the carbonate ion, 10 to the negative 4, and that's not squared because that's only 1. And so then the KSP for this is 6.3 times 10 to the negative 12. So pretty straightforward. The main thing is that you should set up your KSP correct, and once that is correct, then your answer is going to be correct.